Now let's move on to the rth term of the binomial theorem of quantity a plus b quantity raised to n. So our formula for this is this one. So the rth term is equal to the quotient of n times n minus 1, n minus 2, 2r minus 1, and divided by 1 times 2 times 3, 2, 3 minus 1, times a raised to n minus r plus 1 times b raised to r minus 1. So how does this work? So in this equation or in this formula, n is the exponents or the exponent, sorry for that, and r is the rth term or the required value or the required term that we are going to find in a problem. Then a is the first term of the polynomial and b is the second term, so it's here. So n is the exponent and r is the rth term that we are going to find. So how does this formula or this theorem important? So for example, you are only asked to find the fifth term, the seventh term, or so on of a polynomial. So for example, you are given this, for example, a plus b, the quantity a plus b raised to 10. Then you are asked, what is the eighth term of this polynomial? So if you don't know this formula, you are going to do the that the topic or the lesson that we have discussed earlier to find the eighth term of that polynomial. So you are going to expand the polynomial in order to find the eighth term. And imagine you are just concerned with the eighth term, but you can you have to find first the first term, second term, up to the eighth term. So that is quite time consuming. So that is why this formula is important. So we can understand it further if we have an example. So just like this. So it is raised to 7. So we are going to find the fifth term of this equation. So if you do not know the formula to find the rth term of a polynomial, then you are going to expand this kind of equation in order only to find the fifth term. So let's start. So first, to make it easier, you can write the corresponding values of the variables that we have discussed earlier. So n is equal to 7, which is the exponent. R is equal to 5 because we are going to we are required to find the fifth term, and r minus 1 or 5 minus 1 is 4, and n minus r plus 1, 7 minus 5 is 2 plus 1 is equal to 3. And then a, which is the first term, is 2x squared, and b, which is the second term, is negative 1/3 y. So take note that in this in this topic, you must carry the sign of the coefficients or of the variables here. So now let's substitute this to the formula. So we substitute the value of n, which is 7. So this means that we will have the number of terms here depending on the result of r minus 1. So here we have r minus 1 is equal to 4. So that's why we must have 4 terms here. So 7, and here 6, and here 5, and here is 4. So that's how it works. Then the same also to the denominator, we must have 4 terms here. So 1 times 2 times 3 times 4. And then multiplied it by the first term raised to the value that we get here, which is 3 times the second term raised to the value that we get here to here in r minus 1, which is equal to 4. So computing it, we will derive or we will get the answer, which is the fifth term is equal to 70 over 27 x raised to 6 and y raised to 4. So that's how it works, and that's how it is easy to find the art term of a polynomial given this formula. So you can double check that using the expansion of the polynomials. So we can denote that as the long term to find the answer. And of course, you can still do that, expand this polynomial, and there is a 100% assurance that the answer that you will get to the long method and with this equation or with this formula are the same. So let's move on to our second example. Given this equation or this polynomial, we are to find the fourth and the seventh term. So imagine you are going to find the fourth and the seventh term. So again, writing the corresponding values of the variables that we mentioned earlier, then substituting this to the formula, then we will get this equation, and computing this, we will arrive to the fourth term of this polynomial as, which is equal to negative 21 over 2 x raised to 12 and y raised to 6. So again, you can double check it by expanding these polynomials. And the second part is to find the seventh term. So again, write the corresponding value of the variables that we mentioned earlier, and be careful because in this case we are going to find the seventh term. So again, plug in values to our formula, then we will get this equation, and computing these values, we will get the seventh term, which is equal to 672 x raised to 6 y raised to 12. So you can practice more with so many problems that you can find on your book, or you can use the equations that we discussed earlier using this formula. So it depends to you how you will solve a problem. So that's it for this topic. Thank you for watching, and please don't forget to subscribe. And again, if you have difficulties, or if you find it difficult to solve our example in the expanding of polynomials, the problems 3 and 4, kindly comment here, and I promise that I will post the complete solution and answer for that problem. Thank you.